This is the second part to lesson 5.3 as we are working on your slope-intercept form. We really want to hit this last objective, modeling a linear equation in the context of a situation. Remember, a linear equation is used to model it, a real-life situation, and what we're thinking about is what do we have to have? Well, in slope-intercept form, we need a starting value. That's our B. The other thing we need is a rate of change. And a lot of times you're going to see this in a situation as this is how much per year, per month. Usually you'll see that word per. That's telling us that that's changing per whatever our time unit is. So a start position and then the change. Remember, y and x could be different letters if we're looking at a real situation. We always need to have two variables in our equation. Now, from what we remember from that first video is thinking back, what can be our linear situation, linear equation to this situation? Our running back, Adrian Peterson, makes $2.4 million a year to play football. He signed his most recent contract and got $500,000 signing bonus. We want to write our equation. So first thing, what are we talking about? We're talking about his total pay, how much money he gets. We are also looking at over time. So if we're thinking about his total pay and we're talking about in his years of service per year, our starting value, well, what did he start out at? They gave him a bonus of $500,000. Now, since the other number is in millions, we're going to change this to be 0.5 because it's half of $1,000,000. So he got $500,000 to sign for them. What is our rate of change? Well, how much is he getting paid per year? 2.4 million a year. Remember, that's what's changing. So our equation, y, or we could use t, equals, he is getting paid 2.4 a year, our slope, x, or 2.4, and again, if we use our variable as x, plus 0.5. So as we are looking at it, we now want to make a graph. And on your table, right below the situation, I ask you to make a graph. Well, again, we want to look at, this is his pay, total pay for Adrian Peterson. What is, if we are thinking about this graph, what is our independent variable? That should be our years of service that he's giving us. So we probably have something like 1 year, 2 years, 3 years, 4. Maybe he's going to be around 5 years, and you could extend your graph as you are going out on this one. As we look at this, the next thing we want to decide is what is his pay. As we are looking at the pay, this is going to be our total pay. And as we look at the total pay, remember, we are talking in millions of dollars. So this would be our label of millions. And again, remember, he started at 0.5, but he's going up by 2.4 a year. So the question is, could we have 1 million, 2, 3, 4, 5, and if we are starting our scale, we're going up by ones. So if he saves his money and does a nice job, he's getting paid pretty well. Remember, at year 0, his signing bonus, just for signing with the Vikings, was at 0.5, so half. But after a year, where is his salary going to be? So after a year, he has that signing bonus, 2.5, plus the 0.5. And if it helps you to think of a table of values, you can use a table also, like we did earlier. At 0, he's at 0.5 million. After a year, he is now at 2.9, or almost $3 million. At the end of the second year, he's going to go up another 2.9, so almost, or another 2.4. So from 3, we are almost at, if we are looking at that, 3 plus the 2.9, as we are looking at that, year 2. So 2.9 plus our 2.4 to give us our next value. And as we continue going, we are going to see that this is linear. The question you want to think, is it discrete or is it continuous? And in this case, for his pay, we are looking at it being continuous over time. He's usually getting paid probably per month. Okay, with your partner, or as you look at this, think about this one. A plumber charges $65 to repair plus $35 per hour. Write an equation that gives us the model of our total cost in relation to how many hours it takes. And then we're asked to graph it. If we think about this, what is our starting point? How much does he get paid regardless if he only works half an hour or an hour? Gets paid, our starting point, or our y-intercept in this one should be 65. What is our rate of change, our slope? He's getting paid $35 per hour, per 1 hour. So our equation, T equals, as we are looking at this equation, 35x plus 65. Now, when we look at our graph, we want to think about our dependent and independent variable. This is, again, time in hours. So our time in hours. Hopefully we're not having him in our house for more than 5 hours. Sometimes that happens. So we have our time in hours. And then over here, we're going to have our pay. And our pay in this case would be in dollars. Now you want to think, what should our scale be as I'm going up? If I'm looking at this, he gets $65 to start off. So maybe I want to go by 50. So I have $50. I have $150. I'm going to have $200 and $250. So I can see it's going up in increments of 50. If we start off in our graph, again in this case, we would be looking at, for 0 hours, got paid 65. We want to think about that. You probably aren't going to get $65, but we're going to put it as a point on our graph. After 1 hour, this person is going to get $100. After 2 hours, we add another 35 on to our $100, so we're at 135. At 3 hours, we're at 170. At 4 hours, we're at $205. And in this case, should we be continuous or discrete? Think about the time he's there. Is he just getting paid per hour? We'll talk about that tomorrow in class. Here's some things for you to think about. As you are getting prepared for this lesson, do you understand? If you're given an equation with a slope of 6 and the y-intercept of -4, can you write an equation? In the second one, how do you write an equation in slope-intercept form that goes through these 2 points? Well, what are your steps? First step, remember, find the slope. Second step, solve for b. How do you solve for b? You replace or substitute the x, the y, and the m into y equals mx plus b and solve for b. Still haven't written the equation. The last step is writing it in the form y equals our slope times x plus our y-intercept. And then think, can you graph this equation? Tomorrow in class, we'll be working on these examples and more problems like it. Have a nice night.